Today, we're going to talk about evaluating exponential expressions, which is a continuation of converting from radical to exponential form and vice versa. So we already learned this little formula here to go from exponential to radical. So I'm going to write that on the top of our worksheet. So we're going to use this formula when we're evaluating exponential expressions. And it's mostly because square roots and cube roots, etc., or fifth roots, whatever really number you have, are pretty easy to find if you have a calculator. So I like to break these down when I'm actually evaluating or solving. Instead of just putting the whole thing into radical form, I like to break it down into two parts. So I have a 27 and an M6. So we learned in the last video, which if you haven't checked that out, check out exponential and radical form video first, that you could rewrite this expression with the base underneath the radical, so whatever's in parentheses, and your little 3 inside the radical, and your little 1 on the outside. And that is kind of where we stopped when we were converting from exponential to radical. But for these particular problems, since it says evaluate, you can kind of think of solving. So for solving, we want to break it down into two problems, and that's going to make life a little bit easier. So we're going to focus on the 27 to start. And then as a separate problem, we're going to focus on the M6 and the 1/3. So for this part in particular with the number, it's easier if you take the root first. So we're going to try to find the cube root of 27. There's actually a way you can do that in your calculator. So if you hit the second button, and then whatever root you're trying to find, hit that number. So hit the 3. Then hit your, I did that backwards actually. So we're going to hit the 3. Sometimes I have to do it first. Yeah, we're going to hit the 3 first, and then we're going to hit the second, and then this little button that looks like a roof of a house. And that's telling the calculator to put the 3 in for X. So we're going to find the cube root of 27, and that gets us 3. And since it's 3 to the first power, that just means our answer for our number part is 3. For the second part of our problem, you can leave it in radical form, or you could actually leave it in exponential like it was before, and simply distribute or multiply the fraction. So I could put this 6 over 1. So I have 6 over 1 times 1 over 3, which is 6 over 3 if I multiply straight across, which reduces to 2. So that is my new exponent for m. So when I go to write my final answer, I'll take the 3 as my number. I'll take my variable m and my exponent of 2. So you don't really have to do this first part because we broke it into 2. And technically speaking, you don't really have to do this part. You can take what you have over here to begin with and simply multiply and divide to find your exponent. So let's try out on this one, breaking that down into two problems right away. So we have our radical, and we're just going to take our 16. We have our m and n. So we're going to take our 4 on the inside of our radical and our 7 on the outside. In our calculator, we can find the 4th root of 16, if you don't know it already, by hitting 4, second, this key right here that looks like the roof of a house, and the 16. So we know that the 4th root of 16 is 2, but this time it's 2 to the 7th power. So we'll do 2. If we want to raise it to the 7th, we'll hit this button right here, the roof again. That's raising the number to the power. Think of raising the roof. Okay, that's cheesy, but it works. So 128 is the first part of our answer. For the second part, we're just going to use our variable with our exponent. We're going to bring our parentheses, and we have that 7 over 4. Put our 4 over 1. And to find our new exponent, we're going to multiply the two exponents. So we'll do 4 times 7 is 28. And 1 times 4, which is 4. That reduces to 7 or divides, so you can always check in your calculator. So our new power of p is p to the 7th. So when we go to do our final answer, you can either just circle all of that, or you can write out 128 p to the 7th. Sometimes they're a little bit simpler, like number 3. We got a little lucky on that one. There's no number, so we can just focus right on that variable part. So we can simply just multiply our exponents. You don't have to put these 2's over 1 because they're whole numbers. So the new power of n would simply be 4. I really like that one. Number 4, we have our 2 separate parts. So we'll start with our 81. We'll put it in our root. Remember that our bottom number goes inside, our top number goes up high. It's kind of a cute way to remember that. Bottom number inside, top number up high. And you can also use the little formula. The square root of 81, you might need your calculator for that one. So you hit second, and you can do the same. You can do it the same way you did the other ones, like so 2, second, and the house key, and then put the 81 in. But this one's kind of nice. If you want, you can also just hit second and x squared because it's a square root. You can do that one in your calculator with just those 2 buttons. So the square root of 81 is 9. And then we have to raise 9 to the 3rd power. So 9 with the little roof button. To the 3rd, raise the roof. We got 729 as our first part of our answer. And then over here, we have our x2 to the 3/2. We're going to put that 2 over 1. So 2 over 1 times 3 over 2. Multiply straight across, 6 and 2, which reduces to 3. So that would be P3. So the answer would be 729 P to the 3rd. Putting those 2 parts together. Because this one's a little tricky, let's break down number 5. Let's do another one. So again, we'll start with our radical form, which is our 100. 2 is on the bottom, so we'll keep it inside. 3 is on the top, so we'll put it up high. Or you can label m and n and use your formula at the top where the n goes inside and the m goes outside. The square root of 100 is 10. And then 10 to the third, we'll do 10 with the little button to the third is 1,000. And then over here, we're going to go ahead and multiply our exponents straight across, which is 24 over 2. So our new exponent is 12 for x. If you want to just circle all of that or underline all of it and save yourself time, you can do that. If you want to write it all together, you can put it all together in one nice little final answer box. If you want help with this one here, we can do this one as our last one. So we can put our 64 under the radical, put our 3 inside and 1 above. So we're starting with the cube root of 64. Once again, we want to do 3, second, the little house key, and that's going to put the 3 in there. That's going to give us our cube root of 64, which is 4, and 4 to the 1, which is just 4. For our n, we got n12 and 1/3. You might be able to do that one in your head because 1/3 of 12 is 4. Or you could put the 12 over 1 and multiply it by 1 over 3. So that would be 12 over 3, which is 4 as well. Just remembering that this one has an n. So our new exponent of n is now 4. And we put it together as our final answer as 4n to the 4th. So this is how we evaluate exponential expressions, by first transforming them into radical form for at least the number part. And then using our properties of exponents, multiplying exponents, putting it over 1 when you need to. And that is pretty much it. Let me know if you have any questions, and I'm here to help out.